Good day, everybody, and thank you for joining the Animal Welfare Group Nigeria program today. Today is the 8th of the virtual inaugural lectures that we have been holding on this platform. And if today is your first time, we really appreciate you for joining us. The Animal Welfare Group Nigeria was founded in the year 2019 when researchers and students at the Federal University of Agriculture, Abeokuta, Nigeria, who were interested in animal behavior and welfare came together, and we felt it was time for us to establish a network of students and researchers who are interested in animal behavior and welfare. And then we started our webinar series and also the virtual inaugural lectures. And over 3 years now, we now have about 80 members in different parts of Nigeria, cutting across 22 affiliations in the country. And our mission is to foster collaboration amongst researchers in animal behavior and welfare. Our second mission is to educate the public about the importance of animal welfare. And thirdly, to increase awareness in animal behavior and welfare. And I am Dr. Yasiri Oluwaseun Sarah. I'm the coordinator of the group. I am an associate professor at the Federal University of Agriculture, Abeokuta, Nigeria, and a George Foster experienced researcher at the Humboldt University in Berlin. So I'm happy to welcome each and every one of you to today's meeting, and I hope you find it insightful. And with that, I would like to take the bio of our presenter. Our presenter for today is Professor Daniel Very. He is a professor at the University of British Columbia. Dan did his BSc and MSc at McGill and his doctorate at Oxford before co-founding the UBC's Animal Welfare Program, where he now co-directs this active research group. Dan's research focuses on developing measures for the assessment of animal welfare and developing practical methods for improving the lives of animals. Dan's animal research has helped lead to the changes in management practices, including the adoption of higher milk rations for cows and pain management for disbudding, and housing methods, including the adoption of pair and small group rearing for pre-weaned cows. Dan has also led research on attitudes regarding animal care practices with the aim of identifying areas of shared concern, as well as barriers to adopting practices that can improve the lives of animals. With that, I would like to invite our speaker, Daniel, to go ahead with his presentation. Thank you so much.
Thank you very much, Jen. What a pleasure to be able to do this, and thank you very much, attendees. It's nice to see some familiar faces out there in the virtual audience, and as well as to see so many new people that I've not yet had a chance to meet. So, anyways, thank you very much for coming today. I was saying to Sian before I started that I feel I was especially pleased to receive this invitation because I feel in a way I'm going back home to Nigeria. I spent the first 5 years of my life living in Nigeria. My parents were teaching there at the University of Ibadan, and so some of my very first memories are from Nigeria. So I have a special place in my heart for that. Today, I'm going to be talking about a topic which is both quite theoretical, philosophical, one might say almost, but also extremely practical. I was at a meeting last week attended by Penny Hawkins from the RSPCA, who some of you may know, and she made the claim that ending suffering in animals is our most urgent challenge we have as people interested in improving animal welfare or improving the lives of animals in any way. And there's lots of different aspects that we discuss in animal welfare, and lots of different projects that we address in animal welfare science. But I agree strongly with Penny in that our biggest moral challenge, I guess I'd say, is really in coming to terms with identifying and ending sources of severe suffering in animals. And I guess I'd also say it can sometimes be a hard topic. There are more fun areas to work on in animal welfare science, but I think it's our most important topic. So I'm going to be talking today about ways of assessing affective states, basically the felt emotions of animals. But I'm going to be focusing almost entirely on negative states. And indeed, the latter part of the talk, I'm really going to get into some ways in which we can maybe better understand how these kinds of negative states can have compounding effects upon the animals, which I think lead to more severe states of suffering. So maybe we can come back to that in the end and in the question period, if you'd like. I also apologize from the outset that it's 5 a.m. for me here in British Columbia. So if I appear a little bit sleepy or slow in answering questions, you'll excuse my put down my brain fog, I hope, to the early hour of the morning here in Vancouver, British Columbia. Okay, I'm going to start off with a story. And that's a story about the animal that I know best. This individual here, Benny, our golden retriever. And this is a picture of I took of Benny in a winter now many years ago, where I'd been out walking with him at about close to midnight. And for those who know Vancouver in the fall, and this is sort of November, it's very wet. So it's our rainy season, basically. And we had lots and lots of rain. It's quite cold. While walking the dog, I didn't really want to be there anyways. And Ben sees the most exciting thing a dog can see at night in Vancouver, which is a skunk. And skunks are a beautiful member of our local urban wildlife. And their only disadvantage is when they are scared or harassed by a dog or by another animal, their defense mechanism is, of course, to release this terrible smell. And Benny didn't know how to respond. He just kept on sort of going to try to make friends with the skunk. The skunk was having none of it, and he got sprayed and he sprayed and sprayed. And so I brought him back, and this is him trying to get into our back door. Benny is cold and wet and covered in the smell he doesn't know how to deal with. And desperately wants to come in the house. And the last place I want him to do is come inside the house and spread his smell all around inside the house. So this is Ben and I having a conversation at our back door about whether he should come in the house. Now, you can maybe try to make some kind of guess about what Benny was feeling at the time. And me as a dog owner, I'm quite certain that Benny was of course cold and wet, as I mentioned, and was probably anxious from this sort of bizarre experience he had, uncomfortable with this very strong smell, which of course is particularly difficult for a dog with its heightened sense of smell. And as I look at this picture, I can sort of imagine the kinds of emotions that are going on in Benny's head. And as I guess I can say, as sort of Benny's friend and companion, I don't doubt for a minute my ability to make some strong inferences, conclusions about what Benny was feeling and the steps I could do to help Benny. But as a scientist, then of course there are questions about, well, what exactly is Benny feeling? And of course, this opens up a broader philosophical question that happens with any two beings, with any two individuals within our species. We can never be 100% certain what somebody else is thinking or feeling, and so there's a certain gap there. But there are, of course, many ways of closing that gap, and there are now in animal welfare science many also approaches that we can use to make a series of progressively strong conclusions about what the kinds of felt emotions that animals are experiencing, and I'll talk you through those. As I go through, though, I do want to come back to this idea that I don't for a minute want you to abandon your everyday instincts and sympathies we have about our understandings of animals and our treatment of the animals that we, and how that affects the treatment of the animals that we know. But from time to time, as academics, of course, we'll come across skeptics for whom demand higher levels of evidence, but also in some cases we might be quite wrong about our intuitions, especially about animals that are very much unlike us. They may feel and experiencing things that we are unable to experience, or experience at a far lower level, for example. And so I think this curiosity of trying to understand exactly what it is animals experience and how they experience it, I think is actually one of the largest and most important questions, not just for animal welfare science, but I would argue for the biological and cognitive sciences more generally. It's both one of the most intriguing areas, research questions, but I think also one of the most important research questions. Okay, I'm going to start with some very sort of simple questions, and I'll sort of ramp it up as I talked about earlier. And I talk about a wide variety of techniques. And if there's any of these you want to talk about more, as Sion mentioned, feel free to mention these in the chat as either as we go along or at the end, and I'll try to come back to all the questions. I'm going to break down this talk into sort of 3 different types of questions, which I think we could pose that are critical to understanding the larger problem. One is we see an animal showing some kind of response, let's say some kind of sort of acute behavioral response to a noxious stimuli like Benny and the skunk, and we see that the animal seems to be responding to something, but how do we know what it is feeling? So how do we better understand the particulars? So in this case, is Benny responding to the cold? Is he responding to the anxiety? Is he responding to this feeling of this very intense smell, for, as I said, for a dog with very heightened sense of smell to begin with? A second question we might ask is, yes, the animal is responding, but can we be sure that it actually is feeling bad? In some cases, we might see, in the classic case, of course, of this is quickly removing one's hand from a stovetop, that we see acute behavioral responses, but those are happening independent to feeling bad. Later, of course, if I burn my hand on the stovetop, I might feel pain, but at the time I'm removing my hand, it's not because of the pain. Now, I think that argument is overplayed, that the vast majority of the things we're seeing here, certainly the story I'm talking about with Ben, can't be put down to simple reflex responses, but as a kind of critique we sometimes hear as behavioral scientists. And so I'll talk a little bit about some of the evidence that shows about the complexity of the responses and how we can understand that. And a third critical question that I'd like to come back to, and this comes back to the Penny Hawkins quote that I began with earlier, is that yes, perhaps the animal feels something negative at the time, but does this really matter to the animal? So is this just sort of a passing negative state, the kind of things that we might go through all the time? For example, if I stub my foot on the door on the way out, I might feel a bit of pain, but a minute later I've forgotten about it. Or is this something that has a much more substantive impact on the animal? It has a much larger negative effect on the animal. And so we'll come back to that last question right at the end, as I said. Okay, to get things started, I'm going to show you one of my, I don't know, I was going to say favorite examples, but in a way it's one of my least favorite examples. As somebody who works closely with the dairy industry, it's also something I'm in a way embarrassed about, that this practice is still common. This is, and of course, as probably almost all of you in the room know, the dairy cattle, most breeds are born naturally with horns. In our modern intensive housing systems, the horns can either be inconvenient or dangerous, and so they're often surgically removed. And what you see here is a photograph of a technician at a dairy farm in Ontario, and these are the white little buildings you see are calf hutches. So each one has a calf in there. And this veterinary technician, is going from hutch to hutch and is using a hot iron to disbud the calves. So it basically involves putting this iron that's heated to about 600 degrees centigrade, put it on on the horn bud, and you burn away, you cauterize the tissue around the horn bud, and that prevents the horn growth. And as you can, again, immediately imagine, having a 600-degree iron on your head is going to be painful, and the animal is going to respond. And I'll just show you a video of how this looks. And so for those of you that are, squeamish about these things, you might want to just look away. But this is, as I said, is a very a common, if distressing procedure. So the technicians put the iron on the calf's horn bud, and you can see the animal begin to respond. And normally it needs to stay on for about 30 seconds to really cauterize the tissue. And so the technician will just finish it off, and then that side's done. And that's all we'll show you for now. So you can see then, here's a case, the animal's responding to something. We, of course, have a good reason to suspect it's pain. It would certainly be something that would be highly painful for us. But the animal's also, of course, being restrained by the technician, and the calf might be scared of the technician. There might be other things going on. So how do we know the kinds of behavioral responses we're seeing there are actually to do with the pain per se? And this is sort of, in a way, a very simple kind of experimental intervention we can do, but one that's extremely important. And that is that we can, of course, give the animal drugs that we know are effective at addressing this kind of specific state. And in this case, for example, we can do the very simple procedure of providing the animals with a lidocaine nerve block, which is going to remove the sensations of pain. But the calves, of course, are going to experience everything else. They're still going to have the technician there handling them. They're going to have all the other aspects. They're just going to have that nerve block, so they're not experiencing the acute pain associated with the hot iron disbudding. And so then this next video now is the same technician. It's just moved on to the next calf in the adjacent pen. But before they've done the disbudding, they provided the calf with a lidocaine nerve block. And here they are doing the disbudding. So you can still see the animals showing some responses. This could be because the lidocaine block isn't perfect, although I can tell you from experience it has to be a very good lidocaine block to have the animal this calm. But you can see overall the great differences in behavior. And this is sort of a classic, I could say, in the farm animal pain example of a very simple procedure that we can do, of course, on farm, is not always done, but can be done and has a huge influence on the animal. And coming back to the more sort of theoretical questions I had earlier, we can say clearly that the responses that we were saying really were associated with the acute pain response. In addition to the acute pain response that the animals shows right during the procedure while the hot iron is applied, for anybody in the audience that's experienced a burn injury, you'll know that it's not just the pain that you feel during the time of the injury. There's also a long period of inflammatory pain after the burn. And this, of course, is an issue for the calves too. And I'll just show you some other data which helps again show the way we could use various kind of analgesic protocols to better understand the pain associated with that longer term pain. So I'll just go past that. So here's a slide where we were looking at now the pain. Oops, sorry. We're looking at the pain in these hours after the procedure. In this case, all the animals had received a lidocaine nerve block. Indeed, all the animals had also received a strong sedative, xylazine. So the animals are not showing any response at all right in that immediate period after disbudding. But what we do is we follow the animals for a full 24 hours. And what we're looking here, the y-axis is the number of ear flicks. We can look at a large number of behavioral and physiological responses. I've just picked this one measure because it was handy. What you can see also are there's 4 different lines. You can only actually see really one of those lines very clearly because of the way the data worked out, but I'll just walk you through what those 4 lines are. First of all, we had animals which were properly dehorned or disbudded, like I showed you in the previous slide, and other animals which received the sham procedure. So everything about it looked exactly the same, except the iron was not heated, so that there's presumably no none of the burning pain anyways, certainly none of the postoperative burn pain associated with that. In addition, the animals were either assigned to a treatment where they received an NSAID, a non-steroidal anti-inflammatory drug, in this case ketoprofen, to control that inflammatory pain, and other animals which did not receive the NSAID. And what you can see are the really emerging from the graph is it's the animals that were disbudded but did not receive the NSAID that are showing the really strong ear flick response. The animals which were disbudded and received the ketoprofen are showing almost no response, indeed a response, which is very similar to the sham animals. So it's this kind of combination of treatments can really allow us to drill down in terms of what are the factors that are going on in terms of accounting for a pain response. It also allows us, in this case, to see if there are effects of the drug that are happening, let's say, on behavior that are independent of the pain. Now, we don't really expect that so much for something like an NSAID, but if we're using an opiate drug, for example, then it would be really important to have these types of controls because the opiates will have much more general effects on behavior. Okay. So let's go down. Hopefully you're happy now with that, our first question. You've seen some cases of how we can use these kind of pharmacological interventions to get a better grasp of the type of experience the animal's having. In this case, I focus on pain experiences, but we might also focus, for example, on anxiety type experiences, for which we also have very good pharmacological interventions. Now let's try to think a little bit about that second question that I said earlier. Is that okay? In some cases, we see a response. Maybe we might even see some of those acute escape type responses we saw from the calf. We might say, oh well, how can we be certain that the calf's feeling really anything at all? It could be just a type of reflex response. Now, as I said earlier, I think it's actually quite unlikely in the case of many of the calf responses that those actually would be reflexes. But we have a number of other types of approach that we can use to this question, which really, I think, put that critique to bed and show the complexity of these emotional responses really that are going on. And I'm going to show two different examples, which I think are relevant to this. One is I'm going to talk about the way we can use conditioned place avoidance to look at the experiences animals have, and the other I'm going to talk about approach avoidance testing. So let's talk about the conditioned place avoidance first. This is a study by my colleague Thomas Eddy and others, and Thomas did a lovely experiment where he was looking at the effect of, again, that same experience you saw earlier, that disbudding, but in this case, he wasn't so interested in what the animal's acute responses were. He wanted to look at basically what their memory of the response was, their memory of the experience was, I should say. And so in this case, basically, there are two different kinds of experiences the animals might have. One is that they, in this case, and of course in reality, the treatment locations and colors, etc., are randomized. But in this example, I'm going to show you the animals might have been put into a pen here, which is distinctively colored. It has these blue triangles, and on it, and in that pen, they were disbudded. They were disbudded using the protocol that I described earlier. That is to say, they received lidocaine, they also received xylazine, so they've been sedated, but then they basically wake up in this pen, this bizarre pen with blue triangles, and they wake up now experiencing that postoperative pain that I talked about, that inflammatory pain that we saw from the earlier slide, lasts several hours after the procedure. And in this case, they stayed for 6 hours in that pen, in that disbudding pen. So imagine you wake up from some kind of procedure and you have this sort of headache and you're in this pen with blue triangles. In contrast, there was, oops, go back one. In contrast, in the sham pen, everything is identical, but the animals aren't actually disbudded. So the animals, again, they receive the xylazine, they wake up from the xylazine sedation, but they don't have the headache. They haven't been disbudded. Then what you do is the following day, animals are recovered from the procedures now. You come in and you put them into the middle pen, and the animals then have the choice. Now, remember, the animals aren't experiencing anything at all now. You're not disbudding them. You're not doing anything to them. All they're doing is deciding, do I go into the pen with blue triangles or do I go into the pen with the red squares? And the prediction is that if animals had an unpleasant experience in one of those areas and they remember that unpleasant experience, they'll avoid the area they associate with the unpleasant experience. Basically, they're not avoiding the sensation, they're avoiding the memory of the sensation. That's the genius of the conditioned place avoidance. And this gets us, of course, exactly around the critique that the animals aren't showing some kind of acute, immediate response to the iron in the moment. The procedure hinges on the fact that they're responding to the memory. I'll just show you a couple results from that. Here's one, and that is the amount of time the animals spend in the pen. And as you can see, the animals that experience the sham procedure are spending much more time in the pen where associated with the disbudding treatment versus those animals that actually experienced disbudding. So basically the conclusion there is the animals that had this memory of the pain associated with disbudding are avoiding that pen. Another way of looking at this result is to see whether they end up choosing to lie down in the pen associated with disbudding, and you can see that the animals are largely avoiding the disbudding pen. So that's a type of evidence from the conditioned place avoidance paradigm. And the conclusion from that is, of course, that calves remember the pain after disbudding as unpleasant. So yeah, the two aspects of that is that there has to be some kind of valence. They have to see it as negative, and they have to be able to remember it. We can come back to both those questions later. In those, the remembering things is maybe particularly important. We can come back to that issue in the question period if people are interested later. But let me talk to you about another really clever experiment that Thomas did while he was at UBC. And this approach, this paradigm is called approach avoidance testing. And the cleverness of this is that it basically requires the animal to be making a trade-off around its anticipated experiences. In this case, really it's asking the animal to trade off two different experiences. And approach avoidance is both essentially a motivation to approach and the expected reward, I guess I would say, in terms of what I'll get if I approach, but also the expected negative occurrence that will happen associated with that same behavior. So the trading off, basically, should I come or should I go, depending upon two different things. And so here again, it's sort of a simple apparatus that Thomas built, and he was not only a great scientist, but also a good carpenter. So here you can see there's this lobby area the calves come into. They can hang out there for a while, and then Thomas would actually pull a string, would open that gate too that you can see. And once the gates open, the calf would learn to walk and then later run, because it was such a wonderful reward for the calf, to this area where there's a milk bottle. And Thomas was initially feeding the calf 1 liter of milk, a special treat of 1 liter of milk. And for a young Holstein calf, this is a wonderful reward. And the calves would learn to basically, with almost no latency at all, run from the gate and into the chute. And you can see this dark looming figure over the top of the milk bottle. This is Thomas himself, because as you will come to see, once the calves have learned this first bit, they came and they approached the milk bottle quickly, Thomas would allocated the animals to 3 different treatments. And all of them, one might imagine, were relatively innocuous. They were basically types of injections like calves might receive on a farm every day. One is sort of the most standard form of injecting farm animals, and that's the intramuscular approach. And you can see the needle that we use for it up there. There was also an approach of giving the animals the same, in this case, just a saline injection, but delivering it subcutaneously. This was expected or hoped to be a slightly less sort of invasive way of providing the injection. And then there was a third option, which is of some interest, which is providing the substance intranasally. So basically, the animal approached the nipple, and as it was drinking its 1 liter of milk, Toma went up to it, and it would do one of those 3 injections, or nothing at all as control. And you can imagine over time now the animals learned. They learned that, yes, there's a milk bottle with a wonderful reward, but they also learned, but there's Toma standing over the milk bottle, and when I approach to get that milk, I'm also going to get this injection. And so the animal now has to basically make this trade-off. And again, that's getting away at this idea, from this idea that the animals are doing something that's just a simple reflex. If the animals are showing this kind of balancing of motivations that suggests a much more sort of sophisticated cognitive approach to basically trading off whether I accept this amount of pain for this amount of milk, shall we say. Now, to make things even more interesting, what Toma did is he started the animals off, as I said, every animal started with 1 liter of milk, but over time, he reduced the amount of milk reward they had. So over time, the animals were getting, if you'd like, paid less and less to approach the milk bottle. And Toma felt that this reducing the value of milk over time would help maybe spread out the differences between some of these treatments. So now let's look at the way these results look. So first of all, here's the results when the animals were receiving 1 liter of milk. This is for the first 3 days after the animals had started their injection process. And what you can see is 2 things. First of all, for the majority of predictions, just as I said at the beginning, the animals are approaching the milk bottle almost immediately. So there's a latency of about 0 seconds. I don't know what it is, maybe 4 or 5 seconds for the animals to go from that gate and start drinking the milk. But you can also see just a hint that maybe those IM, the intramuscular group, are starting to separate out. These animals are showing somewhat longer latencies to approach. One animal in particular, maybe 2 animals are showing longer latencies to approach the bottle. That's at 1 liter. But then here's what happens when Toma slowly starts to reduce the amount of milk, again, going to 0.05 for 3 days, and then 0.025 for 3 days, and then finally to no milk at all for the last 3 days. And what you can see is those treatments really spread out as expected. And what do we see? Well, we see that the animals are really least willing to accept the intramuscular route of injection. Now, this, of course, has practical implications. If you're going to go out and give a calf an injection today, I encourage you, if the pharmacology of the substance allows it, to provide that injection in the form of a subcutaneous injection rather than intramuscular injection. The subcutaneous really seems to be much less problematic to the calves than the intramuscular. So that's a practical conclusion. But coming back to the more sort of conceptual point here, what the results also show is really this finely tuned balance that the calf is able to do in terms of deciding how much of this sort of negative experience they're willing to accept in order to receive a positive treat. And it really shows that the animals are both have an understanding of the treat, but also have an understanding of the expected pain, and are able to trade that off in a far more sophisticated manner than I think could ever be accounted for by some kind of a simple reflex response. So yes, calves give up access to milk to avoid an injection, especially an intramuscular injection. So if you can avoid intramuscular injections, veterinarians in the room. Okay. So now let's come to what is arguably I would say perhaps morally or ethically the most important of the questions we're going to address, but also is the most scientifically difficult. And that is, how do we know that these kinds of negative experiences to the animals really matter? The animals are, I've convinced you hopefully that they matter to the animal at the time. It's more than just a reflex. So the animal's feeling it in some ways. They remember these sensations. The last study I showed you of Toma with the approach avoidance results begins to get a sense of how important it is. I mean, in a way, it shows you that the calves are willing, at least some calves are willing to give up, let's say, half a liter or at least a quarter of a liter of milk to avoid an intramuscular injection. So it starts to get at the importance of the experience for the animal. But I think there are more profound ways which we can get at the experience of animals. I'm going to show you 3 different lines of evidence that we've been interested in recently that I think allow us to make stronger conclusions about I would actually go as far as to say the extent of suffering that the animal's experiencing. Okay. The first one, and again, this is now well known in the animal welfare science literatures, is getting at judgment bias test. I always think of Clint Eastwood in this case, who asks the wonderful question, do you feel lucky? What we've done is create these ingenious ways of asking a wide variety of animal species, basically how lucky or optimistic they feel. And I'll show you the approach that we've taken when we apply that to dairy calves. This is a beautiful series of experiments that were originally done by Heather Neve, and then later perfected by Rouen Darras, as well as Benjamin Lacour, using a variety of different approaches. We have this methodology working out very nicely in our lab. But I'm going to show you Heather's results, because she was the first one in our lab. After, I have to admit, after a series of failures, Heather was the first one to actually get this working beautifully. And what Heather did is she brought in sort of a simple computer monitor. So every calf had their own computer monitor. But unfortunately, on the television screen, they had a really boring channel. They either had the white channel, the screen was white, or the screen was red. And the calf could turn the screen on by touching a special little start button. And the animals learned over time. And of course, this was again randomized across calves. But in the story I'm about to tell you, for this calf, the calf learned that if it touched the button and the screen turned red, if it went up and it touched the red screen, it was eligible for a milk reward. And I've told you already about how excited and wonderful a dairy calf is for a milk reward, and so it would go and drink its milk. But if the screen was white, and it chose to approach the screen anyways, then it didn't get the milk reward. Even worse, it had to wait for a few seconds before it could start playing the game again. So it delayed the time to the next reinforcement. So the idea is the animals should learn to approach the red screen very quickly. I'll show you a quick video of what this looks like. There's a calf, touches the button, touches the red screen, and there you can hear it in the corner, just happily drinking its milk reward. It's getting just 100 mils of milk. Hits the white, doesn't like it. Hits the white, still doesn't like it. It's randomly, of course, going the color. And it's red. It touches the screen, and it goes back and drinks milk reward. So the calves learn this very quickly. I hate to admit it, but I think the calves learn this more quickly than my golden retriever. So very good at learning these kinds of tasks, and smart learners. So you have a calf now that you basically told them that, in this case, that red is good and white is bad. And now you go on to the bit about is testing whether the animal is feeling optimistic or not. And we do this in this very simple way of now just providing basically these intermediate shades of pink to the calf. So we can just vary screen color across a wide variety of different tones, you can imagine, some which are closer to white and some which are closer to red. And you can ask, does the animal approach now these ambiguous screens, these screens that they were never trained to associate with anything, but which fall in between the positive and the negative stimuli. And here is the results that you get for the calves, and they're showing just a classic discrimination curve where you see, and these are showing again the wonderful performance of our calves. Those are means and standard errors, and the animals, for both the positive and the negatives, the standard errors are less than the size of the points I'm showing, so the animals are showing very good learning performance. But then you can also see how they're responding to the intermediates, and they're responding, again, exactly as you'd expect. They're responding to the midpoint color and exactly about the midpoint. The ones which are closer to the negative, they're responding to more or less as if they're negative, and the ones that are closer to the positive, they're responding to more or less as if they're positive. Now, so that's for a standard calf. What about a calf? What about if we do something to a calf that we might think will make it feel less lucky. And you will not be surprised that in our group, because we had this interest, of course, in pain, and more particularly it's interested in suffering, the types of pain that might cause longer term or more substantial cognitive effects on the animal, we asked, well, how do animals respond? How lucky do they feel in this kind of task in the hours after they've been disbudded? So Heather did exactly the procedure which we talked about earlier. So all the animals received, of course, this powerful sedative. All the animals receive a lidocaine nerve block, but the animals are waking up with this headache, this inflammatory pain that happens in the hours after the procedure. And she's asking if those animals feel less lucky relative to sham animals that were not disbudded. So there is a Heather disbudding a calf, and there we see the discrimination curve for the animals that have been disbudded. And more specifically, as expected, what we see is this downward shift in the curve where the animals are treating all of the ambiguous stimuli less positively. And in this case, especially the ones which are closest to the negative, they're treating as more negative than they were when they were not experiencing that pain associated with disbudding. So in this case, from this type of evidence, I think we can make the conclusion that these kinds of experiences make the animals feel less lucky. And in particular, I would say it's the pain in the hours following disbudding that's having this effect on the calves. Okay, let's look at another type of evidence. And this time I'm going to show you some results from Benjamin Lacour. Great fortune to work with Ben for a number of years while he's here at UBC. Now, Ben, some of you might know as a lecturer at the University of Bristol, but I still have the good fortune to work with Ben on other projects, including an idea I'm going to talk to you about in the last part of the talk. But for now, I'm going to tell you about some of the work that Ben did on anhedonia. Anhedonia testing is a very is a common procedure on the laboratory animal side. Basically, anhedonia refers to the process of losing essentially this unwillingness to engage in behaviors that were associated with positive outcomes, and maybe more substantially losing the ability to continue to take pleasure in the things you used to take pleasure in, associated with human affective disorders like depression. One of the classic ways that we do this in laboratory animal testing is we see if they stop drinking basically a sugary solution. And what Ben did is he tried exactly the same approach in dairy cows. And so instead of those bottles of milk that I showed you earlier, Ben gave the calves basically a bottle of sugary water. And it turns out the calves also really like to drink the bottle of sugary water. So normally the calves would immediately rush up to the bottle, like you can see here, and they would drink the entire milk, I shouldn't say milk, the entire sort of sugary water treat from Ben. So that would be the standard sort of response to this kind of positive treat that Ben was giving the animals. Now, again, as you can imagine, one of the things we're interested in is, well, okay, what happens to that, to the animal's response to this previously highly positive treat in the hours and days when they are recovering from this painful burn injury. And what Ben found was actually quite a strong anhedonic response. So here's the percent change in the consumption of that sugary treat, with each point showing a different calf. And you can see that the vast majority of calves are below the 0 line, so that are consuming less of the sugary solution in the on the day after disbudding. And in fact, a large number of the calves are either not consuming any of the sugary solution at all, or consuming less than 50% of what they were consuming in the days prior to disbudding. So evidence of anhedonia associated with that pain in the hours following disbudding in dairy calves by Benjamin Lacour. Okay, just brace yourself for a second, because now things get a little bit more complicated, but I'll try to walk you through this carefully, and hopefully it'll make as much sense to you and you'll be as inspired by it as I am now. This is an area that Ben and I are working on actively right now. We're actually just in the last minutes of trying to complete a review paper on this. So I'll try to walk you through carefully, and hopefully it makes some sense. So what I've shown you so far is how negative affect, specifically this post-operative pain and the hours following disbudding, can have this general effect on the animals of having more negative expectations. We saw that from the cognitive bias, and this more and indeed even to the extent of really feeling that they're no longer taking pleasure in things they used to take pleasure in, and this anhedonia kind of response. A question that needs to also be asked is whether or not that arrow can be reversed. And that is to say, to what extent, if you have animals, and if you think about this in terms of the trajectory of an animal's life, and I think most troublingly and most importantly for us who are responsible for the care of animals, if we provide animals with a series of negative experiences that, as I've showed you, are likely to lead to the animal developing negative expectations, does that mean that we've also created an animal that is now primed to be more likely to experience things negatively? So in other words, if you have an experience with unlucky events, are you more likely to treat even innocuous events as unpleasant, that you basically are primed to treat the world as an unpleasant place rather than a pleasant place? And as you can imagine, that could have profound effects in terms of the quality of lives that our animals have, and I think would arguably also profound effects in terms of how pleasant these animals are to work with and be with for the people whose job it is to care for those animals. So let's turn to that idea for a second. I've talked about the way that really for almost the entire talk up till now, I've talked about the way that we almost always think about research on affective states in animal welfare science, and I would say more generally just in the cognitive sciences, and that is, you do something, the animal senses something, and it has some kind of experience, perhaps an affective experience. Okay, so you put the hot iron on the animal's head, and the animal feels the pain, and it shows some kind of response. So that's our traditional model. However, if you spend a little bit more time in the dark reaches of the pain literature, which unfortunately I have, you come to realize that there is also this somewhat more complicated way of thinking about the experiences we have. And that is that our experiences are always the result of not just what we're experiencing, but what we expect to experience. This is what's known as a Bayesian process, after the English mathematician Bayes, who showed the effects in terms of our expectations in probability calculations. But it turns out that same branch of mathematics can be applied, I think, very profitably and importantly to understanding the experiences and even the affective experiences of animals. And I would just say, start with maybe sort of probably a most obvious example for all of you in the room, and that is just what we know about placebo effects in human medicine, and also demonstrated in animals, is that if we're expecting that a drug will, let's say, result in the experience of less pain or less unpleasant experiences, then of course we show benefits from that drug, even if the drug doesn't contain anything at all. So even if the drug is neutral, the fact that we are expecting it to be beneficial has beneficial effects on this. This is a well-known phenomenon. And it shows that, of course, that it's not just the sensory input that's resulting in experience, it's a combination of the sensory input and the expectation. And I just want to for us to think a little bit about that, and in particular think about maybe the profound ways that can be affecting the the full lived experience of animals, the affective experience of animals, in terms of often the many negative, but arguably some positive things that they might have in terms of their expectations of interactions with us. I also want to come back and bring some of the sources of evidence we just talked about earlier together. Specifically, here's some lovely data that Ben had, where, as I showed you on the left-hand side already, is the anhedonia responses. So here are those calves which are showing less and less milk consumption. I shouldn't say milk consumption, sweet sucrose solution, sweet water solution, and the hours after disbudding. And you can see that group of animals in the red that are really most affected by that disbudding. And what Ben asked in this study was, well, who are those animals? And what he did is, before the disbudding, he did a type of cognitive bias test that I talked about earlier, and he calculated basically how pessimistic those animals were before the test even began. And what he found is that the animals which showed a low pessimism score are the animals which showed the least evidence of an anhedonia type response to disbudding. But those animals which were already quite pessimistic before even experiencing the disbudding then showed a much more profound anhedonia response to the disbudding. So the animals on the right-hand side of the graph there on the right. So these animals with a high pessimism score then are the ones that are showing the strongest anhedonic response. The animals showing the lowest pessimistic score are showing little, if any, evidence of anhedonia. So this is a type of evidence that we could use to indeed pull together these ideas that it's about not just what the animal's experiences are, but what the animal's expectations are going into an experience. So that's a point number one about these kind of Bayesian processes, which I think might be very important in terms of causing suffering to animals in the longer term. I have one other now, maybe particularly contentious idea that I'd like to turn to, I'd like to leave us with, and it really relates to what might be an up until now a completely unconsidered form of suffering that animals experience, and again it relates maybe to, or is importantly involved in these kinds of Bayesian processes. And that is that there is evidence, certainly in the human literature, that negative experiences, especially more profound negative experiences, can begin to shut down an individual's ability to basically apply this type of Bayesian reasoning at all. It either makes it difficult for the animal to remember experiences. More importantly, there's good evidence that seems like a series of unpleasant negative effects, if sufficiently severe, can make it difficult for the animals to update their expectations. In other words, the animals can get stuck in basically a negative state. So we all go through positive and negative things. It's okay to learn that the world is negative when it is negative, but it's really important that we're able to recognize that the conditions have improved when they've improved. And essentially, the argument is here that people, and arguably animals, can get stuck in a phase where they're unable to update their expectations and maintain these negative expectations far more likely than is reasonable. And it's also possible that the animals the animals' cognitive abilities are so impaired that they're just unable to remember or to access or to make sense of their expectations in relation to sensory input to make good conclusions about how to respond. Now, these are still very early ideas. This has not been properly tested in animals, but I want to show you some of our very first approaches at how we might begin to get at these issues around understanding the effects of negative affective experiences in terms of the way animals learn and remember. And here again is a very recent experiment by Benjamin LaCour. And what Ben did in this case is he developed a version, and for those of you again who are familiar in laboratory animal cognition work, might be familiar with the whole board test. A whole board is basically a matrix of holes drilled into a floor, and in some of those holes there's a treat. And you can imagine if you let a mouse
or a rat free in that area, the animals learn over time which holes are rewarded. And over time, the animals get very efficient at going to the rewarded holes and ignoring the unrewarded holes. So it's a type of learning and a type of learning test, basically, that you can apply. Now, calves won't respond to that kind of task. So Ben invented the calves version of a whole board test. And what you see here are 15 individual milk bottles spread around a room. But what Ben trained these calves to do is that only 4 of those milk bottles are rewarded. And first, I'm going to show you a calf. This is after a period of training. The animals learned which milk bottles are rewarded, and it shows you how well the calves can do. And the calf is going to immediately run up and visit the 4 rewarded bottles, and they're going to ignore the other bottles. So here's a calf, runs up straight away to one of the rewarded bottles. Just remember where that location is, and you can see happily drinks the, I think it's a half liter of milk or a quarter of liter of milk that's in that bottle. Finishes it off, goes to the next rewarded bottle, again, drinks it. You can see the animal happily drinking away at its milk. Then goes to the 3rd rewarded bottle. Beautiful, finishes it off, goes to the 4th rewarded bottle, and that's it. So a perfect performance, has visited all 4 of the rewarded bottles and didn't visit any of the unrewarded bottles. Okay, now I'm going to show you this exactly the same calf on the next day. The only thing that's happened on the next day, this isn't a pain example, it's a different type, I guess you could say, a different type of suffering that our calves experience. But this is a calf, even though the calf, of course, is very happy to get a milk reward, this is a calf that's been fed a lot of milk in its regular life. It's receiving a daily milk ration of 12 liters a day, which is a very good milk ration for a dairy calf. But our protocol at our farm is to gradually wean our calves. And one way we do that is when the calves reach a certain age, the milk ration gets reduced in half. So basically what's happened is over the past 24 hours now, the calf has only received 6 liters as opposed to 12 liters. And so we expect that the animal's much more hungry, and it comes into this pen now, and it's asked to do exactly the same task that I've already showed you it knows how to do very well. So here's the calf, and it comes in now, as I said, the following day, but hungry. And it finds the first bottle, but it only drinks part of it. It ignores the second bottle. It can't find, or doesn't seem to be, oh no, it's found the next one, but doesn't drink at all. Comes back to the wrong bottle, was never rewarded, licks it for a while, kicks, goes back again to some unrewarded bottles, back again to the bottle it finished, vocalizes, etc. Now finally it finds one of the other bottles. But you can see the performance now of this animal in this sort of hungry state, doesn't even finish the milk meal, comes back again, vocalizes. So this type of visiting many more of the unrewarded bottles, revisiting bottles after they're finishing these kinds of performance, basically evidence of impaired cognitive performance that you can get from this kind of a whole board test. So the conclusion from this kind of study is that the negative affective states certainly do seem to interfere with learning and memory recall. And I would say, coming back again to that broader argument, is that this kind of inability to basically make sense of the animal's current world, in this case, to properly access its memories and act upon them, is setting the animal up for other failures, which of course are then compounding the original insight. So here the calf only got, has already on reduced milk rations, and it's also unable to perform well when it comes to getting these treats. So you can see the calf's response as a result of that. Okay, so let's go back now and just try to bring all this together with some general conclusions. To begin with, I showed which I think hopefully in retrospect seems like some very simple kinds of approaches, testing animals, for example, with and without pharmacological agents that we know are able to either create or remove specific feelings, and how that approach allows for strong inferences about exactly what those feelings are. And I think there's a very nice series of studies there, and those can be beautifully applied to a wide variety of issues for those of you that are interested in understanding, the effects of a specific sensation. I also showed some approaches, specifically the conditioned place avoidance and aversion avoidance testing, and how these kinds of tests allow for inferences about how animals are able to balance their motivational states. And then finally, in the last series of slides I showed you, I talked about procedures like judgment bias testing, anhedonia testing, and other kinds of cognitive tests that allow for inferences regarding the longer term or perhaps more systemic impacts of a negative affective experience on the animals. And I would argue that it's these kinds of impacts that perhaps are the strongest evidence of important suffering for the animals, and would be our highest priority of areas to really try to understand and address when it comes to improving animal welfare. So just leave you again with this image of Ben, and come back to that point that, of course, I never doubted about the experiences that Ben was having when Ben was there struggling to get into my back door. But I do think these series of studies that I've told you today take us considerably ahead of these kinds of sort of well-meaning but ultimately subjective responses that we of course immediately have in our own interactions with the animals that we know. For example, I would never have guessed before we started this work that something like the pain after disbudding would be resulting in these kinds of judgment biases in calves and these kinds of anhedonia responses. And this entire line of thinking about how we may be, in fact, setting animals up to have negative expectations around their lives by the things we do to them, and how those negative expectations in turn can both set the animals up to experiencing the everyday things in life more negatively, but perhaps even in some cases, even interfering with or dismantling their ability to properly access their memories and to make informed Bayesian type reasoning decisions about how to respond to future stimuli, which sets the animals up perhaps for very negative life experiences indeed. So on that note, I really look forward to your questions, and thank you very much for your interest today.
Thank you, Dan, for the wonderful presentation. Thank you so much. We appreciate you for, talking us through this interesting topic. Dan, there is a question from Edna Hillman. The question is, a lidocaine injection might be even more aversive compared to a controlled injection. Do you think this would play a role in the decision of doing local anesthesia or not?
I mean, this is a very good sort of question and discussion for people that are sort of in the practical business, certainly in the practical side of sort of farmer education. I would say a couple things in my experience. First of all, I would disagree with Edna about the lidocaine being worse than not lidocaine. Maybe for a trivial procedure, certainly a non-buffered lidocaine can cause some irritation. Of course, it could be buffered to cause much less problem, but a non-buffered can cause some irritation. But lidocaine is an amazing drug. in that it's that doing that nerve block for a procedure like disbudding, if it's done properly, has this almost magical effect in terms of making the procedure much better for the animal. My biggest problem with the way I see this being done is that actually, even though it should be quite a simple procedure to give a lidocaine block for disbudding, it's not. It's easy to do wrong. And if it's done wrong, then what you have is an animal that still shows a full response, plus the farmer, especially if they're not used to giving the injection, is having to, hold the animal, give the injection, wait a few minutes, go back. It's one of these things is, oh, well, is it really worth it? I did all that work. And, imagine if you have quite a wild animal. I've had this experience, for example, working with beef calves, which here in British Columbia are really reared in a very extensive situation, where if you had to go catch the beef calf and then give it the injection, and then come back 10 minutes later, you're doing a double procedure. And that would be bad enough. But then if you've done the injection poorly, so the animal's not receiving the pain control, then that would be particularly sort of demoralizing for all the individuals concerned. In a dairy situation, you can absolutely train people very well. We can talk about that later, how to give a lidocaine injection properly. And I have absolutely zero hesitation in terms of recommending that. Maybe Edna's referring more generally to this issue of animals which are very wild, and it refers, and it could be for any kind of treatment. Is it worth it to the animal to be captured and handled a second time to avoid the pain? That's a complicated question and would require quite an elaborate series of studies. I think you could get at that with something actually like conditioned place avoidance if you wanted to, but that would be a longer conversation between Edna and I, or anyone else who's interested in sort of teasing apart these more complicated questions.
Thank you for the answer to that question. There is another question from Lana Kaiser. She says, in general, in the US, maybe Canada also, dairy cows are not fed ad libitum like beef cows, and generally are not fed the amount they would prefer for satiety and growth. Do you think cows were fed as much as they wanted, they would find the milk reward less rewarding, therefore be less likely to work for milk?
Okay, two important questions there. I mean, I'll try to break that into two questions anyways. Thank you very much for the point. First of all, very important. Yes, as a general welfare issue, and I sort of hid that in, I talked mostly about pain, but I also hid in a little element of hunger right at the very end there. I actually think the hunger for the dairy calves is a huge issue. Most calves are much underfed. And this is I would say is probably the largest welfare problem for calves in the United States right now. And yes, of course, we have 100 years of work in experimental psychology, which will tell you, I mean, it's not completely linear, but animals that are that are receiving a little bit less. I mean, a classic case, if you're running a rat or mouse experiment and you want animals to be highly motivated for a food reward, is you would maintain the animals at a diet slightly less than their ad libitum diet, so they show more interest in a food reward. In this case, as I said, in our studies in UBC, we feed the calves very high rations of milk. They're feeding them typically 12 liters of milk. This is easily double. It's actually probably 3 times as much as the average milk the calf gets in the United States. But still the animals are motivated for the food reward. So, but yeah, the calves would be even more motivated if we're feeding them 8 liters or 6 liters, or God forbid, 4 liters is commonly done. The calves would be even more motivated for milk. But I would not encourage any researchers out there, please feed your calves lots of milk. The calves will still be highly motivated for a milk reward, even at quite high milk rations. However, coming back to the hunger issue and that's why that last study, remember that last study that had that profound effect in terms of creating this very clever calf that knew exactly where the rewarded bottles were. And all of a sudden it wakes up one morning and now it's receiving 6 liters. Remember, this is 50% more than the average calf gets in the United States. It went down from 12 liters to 6 liters, and now it's no longer able to access its memory. It's no longer able to remember. So that profound effect on the animal. So yeah, is hunger a really important affective condition we need to be serious about? Absolutely. Do we know how to solve that problem for the milk-fed dairy calf? Absolutely. Do we lack sometimes both the moral fiber to say that loudly and shout that from every rooftop? Perhaps. And is it in the industry hard to convince sometimes to change their practices? Absolutely. But it's a really important, sorry to get passionate on this one, but this is a really important issue for us all to address around the world in terms of making sure that, of course, our young animals are fed properly. And of course, this has, I've talked about these much more sophisticated affective responses here. You don't need anything anywhere near as sophisticated as that. You just need to weigh your calves. If you feed calves more milk, they'll grow properly. So this is sort of basic animal science 101. And it's an embarrassment, to be honest. I love the dairy industry deeply, but I am embarrassed by the fact that we still don't do a better job of feeding our calves better.
Before I go on with the questions, I would like to take you up on that concerning this issue of the feeding of dairy cows. I want to know your opinion about the current method of rearing dairy cows, where they are separated almost a few days, or almost immediately from their mother. And I think I read one of your paper that talked about the different, is it a suckling type, or maybe a restricted suckling or something? So what is your own opinion about it? And do you think that cows that are separated like this from their mother, what impact does it have on them emotionally, and based on, maybe you've done any study looking at the cognitive bias of these cows? Yeah.
A very good question. Thank you very much, Jen, for bringing that up. And a couple different levels. And of course, like lots of our issues in animal welfare science, and I want to reinforce that for this audience, this brings together both profound issues, basic issues around cognitive sciences, but also very important practical issues. And I think that's one of the wonderful things for students interested in this area, is that, and I really feel that over the course of my career, is that these little experiments we've done over time, they do result in changes in practice. And so things can and do change even in our large industries like our dairy industry. But at the same time, we end up doing approaches which are actually, I think, scientifically very important and can help push forward the basic literature as well as the applied literature. But on this issue in particular, I'll give you just a couple different points there. One is, whenever you're talking about this, maternal infant bond, then you have to consider at least two individuals, the mom and the baby. And the mom and the baby, their interest, and as you'll remember, for those of you that sort of remember reading sort of Robert Trivers' 1972 classic, but ever since then anyways, the mums and babies, of course, can sometimes have the same interests and sometimes they have different interests. Anybody who's had a teenage child will know what I mean. So this is, and that's normal and natural and fine. But it's important just to consider those interests differently. In this case, I actually think we can do a reasonable job of caring for baby calves with early separation. I don't mean that we always do, but we can do, because really for that baby calf, some type of socialization is very important to it in terms of its normal development. So rearing calves individually can be very harmful in terms of its normal development. This is commonly done, but it's very harmful. But we can correct that by rearing the calves even in a simple group as just a pair of calves. Of course, more complex groups are going to be better, but some very simple groupings can help. And as long as we feed the calves enough milk and provide it with some meaningful social interactions, the calf, I think, can do okay. The mother has a harder time with that early separation, to be honest. And can have a more profound effects, including health effects, as we've discussed also in the literature. Yeah, that early separation, of course, I really think we need to desperately be doing research, and I'm really pleased to see all the new research that's happening in terms of keeping cows and calves together. I think there should be good ways of getting that system to work. But from a research perspective, yes. The effects of separation are important to both cow and calf and need to be studied separately. I'll just finish with one last example, and that's this beautiful work that Ruan Deras did, who's now a professor in Curitiba in Brazil. In fact, will be one of the co-hosts of the next ISAE meeting. And Ruan did this beautiful experiment where he looked at cognitive bias both in calves after they've been disbudded, like the data I showed you, but also those calves after they've been separated from their mom. And the degree of cognitive bias that they showed was almost identical in those two situations. And what Ruan claimed there, and I think it's really a lovely case, is we talk in English about this emotional pain of separation, the pain of losing someone you love. And it's almost like we mean that metaphorically, but in this case, really that response on the cognitive bias suggests that pain of separation for the calf, very similar to the pain of experiencing it happening in those hours and days after disbudding.
Okay. Because I'm an advocate for maternal care, because I see it as
Yes.
one of the natural behavior of animals, and I believe they should be able to enjoy themselves. So let's go on. There's a question from Sylvia. How many days are the cows suffering after disbudding? Is it necessary to disbud the animal if this would be so distressing and painful for them?
Okay, no, it's not necessary to disbud calves. Of course, there's lots of cattle in this world that still have their horns. It requires managing the animals differently, basically. So if you keep horned animals, or of course, there's also lots of breeds of cattle on this earth, and lots of individuals within our normally horned breeds, which are hornless, so that are genetically hornless animals. So there are ways of solving this problem other than doing this procedure. It is a important priority for the dairy industry that we move to these naturally hornless or polled individuals. But unfortunately, it's very slow progress. I would say there isn't, or has not been up until now anyways, a lot of enough sort of passion to do that, because of course, as you will know from breeding, if we breed for polled, we might be giving up something else, like some milk production, for example. And so it requires a decision actively to prioritize those polled genetics, and that hasn't been done. It hasn't been done enough up until now. I think there's great opportunity for that. I would say within our intensive production system, the hornless animals probably are the way to go, the genetically hornless way of animals. But of course, in other production systems, horned animals, horned cows are also beautiful animals, and there are good ways of rearing those animals. And we can live in a world where we have both horned and hornless animals, I think.
Yeah, wow, that's amazing. Yeah, that's good. It's good to know. Because I wanted to ask, but you've already mentioned it, that why don't we breed for hornless animals instead of, for them? But it's also linked or coupled with the fact that it may affect their productivity as well. So I think we can't have it all.
Yeah, can I just come back to that for a second, Luciana? Because I think it's interesting. I also do work on laboratory animals and improving the lives of laboratory animals. And I think one of the struggles there, so in farming, of course, there are some people that would say we don't want to have farm animals anymore. We're just gonna, we'll all become vegan and we won't have farm animals. I think that's sort of not only unrealistic in the short term, but also, I feel I have a close bond with cattle, and I wouldn't want to live in a world where we don't have relationships with cattle anymore. For example, I can say that as a cattle person. So I don't even want a world without dairy cows. So I think we have, but in the laboratory animal side, of course, there's much more emphasis put on sort of replacement, moving to non-animal models altogether. And so the question then becomes, well, why should we be doing effort to make the lives better of our animals now? Because we want to be moving just to getting rid of needing the animals at all. And I guess I say it because I spent my whole career doing that. I really think we do have a very strong moral responsibility to be making the lives of those animals better now. And so, yes, I think with disbudding, we need to be pushing our industries to move towards hornless animals. But right now, we need to be finding ways of making that procedure less painful on farms as well. So we need to be doing both. The answer is yes, both.
Thank you so much. Thank you. Sarah says she's appreciating you for your talk, that is quite fascinating and relevant to the work that she does. She works with bears, and I think they also definitely see negative expectations from their animals as well. So the next question, okay, not really a question, from Hildegard Neyman. Thank you so much for this interesting lecture. I work with parrots. Wow, good to see you. Thank you for joining, and see a lot of plucked and screaming birds. This lecture helps a lot. So thank you so much for being part of us. And I think we also have a webinar coming later in the year. I can't remember his name, but he's going to talk about parrots to us. Yeah. So because the animal welfare group, we're not only interested in farm animals, we're interested in all animals. So companion animals, zoo animals, wildlife. So that's what we do, and aquatic animals. So Sylvia is saying, thank you, Professor, and also the AWGN for this interesting talk. Thank you so much. Hi, okay. Ventura, yes, the recording will be shared on our YouTube channel later, and you can watch it. Okay, so, okay, there's a question here from Samuel Dorosharo. Can you talk about the reliability of some behaviors used in assessing positive affective states, such as play behavior, preening behavior, and disbudding in some animals?
Sure, I can I mean, generally to start off, very good to be thinking about the reliability of your measures, and it often, I mean, there's a whole nother talk I could give on this, but just even in talking about the more negative affective states I've talked about already, is that our measures can really be thinking of varying in sensitivity and specificity. So you can have a measure that might be very good at telling you that something's wrong, so it's sensitive, or very poor at it, but let's say a highly sensitive measure telling you something's wrong, but it doesn't tell you exactly what's wrong. And you might have other measures which are very good at identifying a very specific kind of experience, that is, and others which aren't. Our measures often that we use, and I would say maybe especially the physiological ones, but often the behavioral ones, can be very general. Okay, so put your mind back to the very first video I showed you of that calf struggling. Is that because the animal was experiencing pain? I could go up to the calf and not cause it any pain, and you would see all very similar kinds of behaviors. So, you know, I think those are behaviors associated with some kind of general negative experience. Same thing if we measured cortisol, for example. The same thing, you might say, okay, well, I think there's something negative going on here. Certainly something the animal is responding to strongly, but we don't know exactly what it is. And there I showed you that example of how we can, for example, use a pharmacological intervention to make more specific interventions. Even though the behaviors themselves aren't specific, we can basically limit the range of experiences to be able to make stronger claims about the change in behavior. But sometimes the behaviors really are specific. And so, for example, you might have some kind of wound-directed behaviors. So an animal that has had some kind of injury and it's directing, you know, licking that area or rubbing that area, that's be a more of a specific kind of response. Of course, in that case, you can't be sure, is it the pain that's causing them to lick? Maybe it's itch, for example. So again, you might need to use some kind of pharmacological intervention to get it specifically. I think coming back to play, if I just talk about that for a second, I do think actually that behavior is extremely interesting, but I would change it a little bit around the focus to bring it back to something that I've been talking about earlier. And that is these kinds of anhedonic responses. Is that I think, I mean, it's fun to do play research because you see animals play. Who doesn't want to watch animals play? That's fun. So as for enrichment for the applied ethologists, play research is good. But in terms of advancing animal welfare, one of my preferences is because, I mean, and sorry if you think I'm overly negative in this respect, but I come back to that again, that Penny Hawkins quote I started off with by saying that, yes, of course, we should have fun and have enriching lives as applied ethologists, but our day job is to solve severe suffering. And so how do we use play to get at severe suffering? Well, what if animals no longer want to play? Right? That's a type of anhedonic response. If you have animals which were quite playful, and now all of a sudden you see they're no longer taking an interest in that, wow, that sounds to me like something interesting. So, I mean, that's a way, personally, if I had sort of a little bit of a sort of a call out to the play researchers, I would say, you know, I'd be really interested in seeing more studies like that. Studies looking at things that we know animals take great pleasure in, and all of a sudden they stop taking pleasure in that. well, what's happening to those animals? What's happening? And again, coming back to those Bayesian processes, what's happening in terms of the life story of the animals that's resulted in it now no longer being able to take pleasure in things that used to take pleasure in. And now, if you think about this from a holistic perspective, not only have we done the insult to the animal, let's say caused it pain, but we've also robbed the animal of the ability to take pleasure in the things it used to take pleasure in, right? This is a twofold insult. These are the kinds of things that I think we desperately need to, and now it's not just for 5 minutes or 5 days, but maybe for the animal's lifetime, right? These profound lifetime effects that are where I do think there's tremendous opportunity to be looking at the lives of animals from that sort of life story perspective. And I really hope we'll see more of that type of research in the future.
Thank you for that. That's a whole lot to discuss. Yeah, because I have never looked at it from the perspective that if an animal is displaying a kind of play behavior and at some point stops doing it, what really has happened? Though I may not know much, but at times what I've really read, maybe it has to do with maybe the age, and probably they said younger animals tend to play more than adult animals, or probably the adults now have to do something more, goes into reproduction and other things and may not have time to do that. I don't know the reason, but it's a good area that you have just made us realize this afternoon. So from Frania, no cortisol is a cattle stress measure, but for those animals greatly relying on chemo signals, as in cats, dogs, can we not fine-tune these measures? So much they are saying we are missing. I don't know if you really can pick the question.
Absolutely, yes. Thank you, Franny. I agree completely. Yes, I think that's our job as applied scientists, is we're out there trying to do our best job we can to understand the experiences of these animals and to try to make them better. And it requires your ingenuity to come up with the best approaches that you can. And that different animals in different situations will require different approaches. Yeah, and so yeah, there isn't one best approach. I guess maybe on the backside, though, I would say two things. One is that maybe that's a little bit complicated, but one is that don't just rely on, just because this is what people often do, it doesn't make the measure good. So the fact that people have done it a long time doesn't make it good. It's good to be critical of exactly what you can infer from your measures, even if it's all you have, that you understand the limitations of it, and that you more generally help the field advance by making sure that colleagues that are using these measures understand both the strengths and the limits of the measure. The other thing I would say, is that more isn't necessarily better. And so sometimes you see approaches where people will say, okay, well, I've taken 5 different ways of assessing, let's say, negative effect. And I guess my worry with that is that, if 2 of those work and 3 don't, what do you conclude? And does that mean, and so I have a very strong preference for people to really try to think clearly before they start about what their primary outcome measure is, to state that publicly, ideally in a preprint, to pre-register their study by making a clear, transparent claim about their primary outcome measure, and then restricting their statistical analysis to that outcome measure. So yeah, I'm not a big fan of looking at multiple approaches. Well, multiple approaches, okay, but looking at sort of a grab bag, a scattershot of approaches.
Yeah. Thank you. But I realized that during your presentation, you talked about ear flicking
Yes.
behavior. Yeah. But personally, I've observed tail wagging in,
Yes.
Yeah. Does it have to do with a positive experience?
Super interesting. Of course, we know that in our dogs, right? So there's good reasons to look at it. There is some literature on that. I'm not 100, maybe somebody in the audience has a more sensible answer to that. I'm not 100% up to date, certainly not in cattle. I can't sort of cite a perfect study about tail wagging. If for those of you that were attentive might have noticed this in the whole board test and the lovely videos from Ben LaCour. When the calf is drinking, some of those calves were showing this lovely little tail wag when they got the reward, but not all and not always. So my guess at this stage is a bit non-specific. Shall we say, to come back to the language we were using earlier? Yeah, I'd be really interested if other people are more aware of the recent data on tail wagging in cattle.
Oh, thank you so much. Thank you. The next question is from Anna. Thanks for the presentation. It was interesting. Mammals are easier to understand, but how could you understand or read bad expectations of feelings in reptiles and amphibians?
Thank you, Anna. Yeah, of course, super important area. And I mean, I would say, you know, we have this lovely data of cognitive bias in bees, for example. We have lovely data of conditioned place avoidance in crabs. So you know that there are smart scientists working with a wide variety of taxa that are able to develop, and you saw that with Ben of taking that whole board test and modifying it for the calves. I mean, I think it needs to be done with some sensitivity and empathy and understanding of what's important to the animal. And also, and this is where I think, you know, ethologists should be good of learning how to talk to the animal so you can ask it a sensible question. You don't want to ask a calf a question that was set up for a rat. You want to ask a calf a question that's set up for a calf. And it's the same thing. If you want to do a study on a crab, you have to ask it in crab, but you can't ask it in human. Yeah, I'm forever impressed, of course, by those kinds of approaches. Maybe I'll just say a shout out to my unfortunately deceased colleague, Victoria Braithwaite, who did this wonderful work on fish and pain in fish, and this elegant series of experiments, and as an inspiration, I think, of how we can really do that work to really understand the lives of the animals we work with, not just make sort of guesses, but to really do the hard work to understand their experiences, including their rich emotional experiences, which I don't doubt for a minute about the ability of fish or crabs to experience all sorts of things, and maybe experience things that we're, of course, completely insensitive to. Far from believing that their experiences are less rich. It could easily be in some cases, their experiences are far more rich than our own and need to be understood.
Oh, thank you so much. Thank you so much. I think I'll just take this last question and then we'll wrap up the meeting. It's a follow-up question from Frania. And it's also about this corticosterone. She's asking, we measure stress in urine and feces as a non-invasive, and that is a good thing, with unacceptable elimination in dogs and cats. We can be measuring this. We can be measuring these levels, and this in itself can further help the understanding of clinicians and owners working to approach the interventions rather than anthropomorphic reasons we assign.
Yeah, and beautiful again, Brenda. Thank you for sharing that example. I think that as another nice example of not only doing science with what you have, but also, and doing it in a way that's non-invasive, fantastic, but also doing science in a way that directly assesses or addresses something that's relevant to the end user of that science. So of course, owners that have a cat that's peeing in the living room are going to be really interested in that. And so to be working directly with that in terms of helping the owners solve what they see as their issue, as well as helping to improve the lives of the cat, this is brilliant. And I think that's, of course, a case. I mean, that's one thing I'm still trying to learn as a researcher, is when I want to start a study on calves, let's say, is to start off by talking to farmers to make sure that the way I ask the questions, the kinds of research I do, is as much as possible is collaborative with them, is helping to address the real problems they have. And I know this is important because if I don't do that, the farmers, of course, aren't going to be interested. If I do a study that I think is interesting, but doesn't address their core interests, it might be entertaining for me, but is unlikely to ever have any real world effect. So I really applaud the approaches which are more collaborative, and part of that collaboration is really is addressing the problems from the animal user's perspective. And I think also, and I don't know if that's what you're doing in this case, but also having the animal user involved in the research itself, maybe even collecting some of the measures. I think that's wonderful where possible.
Well, thank you so much.
Needs
Thank you so much. I think I've exhausted the questions in the chat box, and Dr. Duru Sharo wants to give a comment. So, Dr. Duru, yeah.
Thank you so much, Daniel.
No problem.
I need to confess to you that I love your enthusiasm about animal behavior and welfare. I love that about you, and I also love the explanation about play behavior. So thank you so much for that.
Thank you for the opportunity to be here, Samuel. Really, it's a pleasure.
Yeah. So thank you very much. We want to appreciate everybody for participating in today's meeting. And we are so grateful to have you join our meeting. And we hope to see you in our subsequent meetings. You can follow us on Facebook and on LinkedIn. That is Animal Welfare Group Nigeria. Just type that on your Facebook and follow us. And if you want to follow us on Twitter, our Twitter handle is at AWGN14. AWGN in capital letter and 14 in number. So follow us. And if you want to, Anna is trying to say okay. We are doing good. So if you want to listen to the past webinars, just go to YouTube, type Animal Welfare Group Nigeria, and you are going to see a lot of webinars, inaugural lectures, and a lot of things that we have been doing. And you are so much going to appreciate it.